Curcumin is a yellow natural colorant used in food and pharmaceuticals, but due to curcumin's poor UV stability, it ends there. Until recent research showed that it is possible to improve UV stability and generate other colors, like red and blue. That is when project partners from Ireland, Germany, Belgium, and the Netherlands joined the Interreg CurCol project. Its mission? To continue this promising research and develop biodegradable yet economically viable packaging dyes. For obvious reasons, curcuma powder is best extracted from Curcuma longa, or turmeric. The cultivation of turmeric generally proceeds without many problems. It can be grown locally and rarely presents problems with pests and diseases. Weeding is required at first, but over time, the crop suppresses weeds. Free-ranging quail can contribute with weeding. Curcumin yields are both high in greenhouses and in plastic outdoor tunnels in Flemish fields. The curcumin content can vary depending on the growth stage and cultivar. The plants build up curcumin over time, and different plant varieties show differences in color. The turmeric harvest comprises 3 steps. First, the haulm is removed using a brush cutter. Then the rhizomes can be removed from the ground quite easily with a potato harvester. Using a brush cutter and potato harvester saves time and the farmer's back. Finally, the rhizomes are manually cleaned. Roots and excess foliage are removed before breaking down the rhizomes into smaller pieces. This is necessary because the erratic rhizomes hold a substantial amount of soil. The remaining soil is washed off. In the second stage of curcumin dye production, the yellow pigment is extracted from the rhizomes by grinding, drying, and solvent extraction. In the third stage, chemical modifications with various natural stabilizers and UV absorbers are carried out to stabilize the dye and create different colors. The CurCol project succeeded in making 2 yellow curcumin derivatives with improved light fastness. In addition, 16 red derivatives were synthesized, some of which also showed improved light fastness compared to curcumin. In the last stage, different polymers commonly used for bio-based and biodegradable packaging were evaluated. These polymers were mixed with curcumin derivatives in an extruder, generating colored filaments. The produced filaments are chopped into pellets, creating a master batch. This master batch can then be diluted with blank bioplastic material to the desired color shade. The master batches were used to produce several product prototypes. In the tape extruder, PLA tapes are generated with the different curcumin colors and at different draw ratios. Depending on the draw ratio, transparent or opaque tapes are obtained, thus changing the color appearance. The thermal, physiochemical, and mechanical properties of the tapes were compared with the properties of PLA without colorant. Also, the UV stability of the colorants in the polymers were analyzed. Since inks are nearly never biodegradable, the CurCol project was keen to explore the potential of curcumin colorants as inks and coatings for the decorating paper packaging. The dyes were ground into pigment pastes containing biodegradable plasticizers such as glycerin. This concentrated paste was then used in printing inks based on natural waxes or biodegradable polymers such as PLA and PHA. After biodegradability testing, the most ecological inks were selected whose technical performance was still acceptable. In short, to resolve the contradiction that current biodegradable packaging contains toxic dyes, curcumin was investigated as a bio-based alternative. The use of bio-based substances does not necessarily guarantee a sustainable process overall. Therefore, the CurCol project ensured that harmless chemicals and procedures were used in every single step of the process. The entire production chain was examined using life cycle analysis, comparing various aspects such as toxicity, recyclability, and carbon dioxide emissions. Economically, the process needs to be further optimized to be able to come closer to a product in line with market demands. Other than that, the CurCol project successfully cultivated Curcuma longa, generated several light-fast colorants, and tested them in various sustainable packaging materials. In other words, CurCol brought us a few steps closer to a circular and bio-based economy.